Okay, we know when an object move, then generally the object move with a different velocity. Or I can say when an object move, the velocity of an object is changing with time. So how fast is the velocity is changing with time, that is known as acceleration. So we define acceleration as the rate of change of velocity. Okay, so this acceleration is equals to change in velocity divided by time. Okay, so this is the equations of acceleration. Okay, for example, if a car move on a straight road, let's say at time t1 the velocity of the car is v1, and after time t2 the velocity of the car is v2. Therefore the accelerations of the car, let me write it as small a, which stands for acceleration. So this acceleration is equals to change in velocity, which means final velocity minus initial velocity, and this time taken mean the final time minus initial time. So this is acceleration. Okay. Next, the SI unit of acceleration, it should be meter per second square. This is the SI unit. And the CGS unit of acceleration will be centimeter per second square. Okay. Now, there are different types of acceleration. The first is uniform acceleration. Okay. So what do we mean by uniform acceleration? So the accelerations of an object is said to be uniform if its velocity is changing by equal amount in equal interval of time. Which means, suppose this is a straight path. Okay, this is the starting point. Let's say the velocity at this point is 0. After 1 second, the velocity, it is 1 meter per second. Okay, and at 2 second, the velocity becomes 2 meter per second, and at 3 second, the velocity becomes 3 meter per second. At 4 second, the velocity becomes 4 meter per second, and so on. Okay, so now when you take the difference between any 2 points, like this point and this point, what is the difference in velocity? Final velocity is 1 meter, initial is 0, so the difference is 1 minus 0 will be 1 meter per second. Similarly here, the difference between the velocity at this point and the velocity at this point will be 2 minus 1, which is 2, which is 1 meter per second. Again here, the difference is 1 meter per second. Again here, the difference is 1 meter per second. So here it means that the velocity is changing at an equal rate. Okay, that means for every 1 second, the velocity increases to 1 meter per second. So if the body is moving in this way, then we say that the body is uniformly accelerated. Or I can say that motion is a uniform acceleration. Okay. Number 2, the second type of acceleration is variable acceleration. Okay. What do we mean by variable acceleration? So from the word itself, it is understood that this variable means non-uniform. For example, when the time is 0, let's say the velocity is 0. When the time is 1 second, the velocity is 1 meter per second. When the time is 2 seconds, let's say the velocity is 5 meter per second. When the time is 3, let's say the velocity is 7 meter per second. When the time is 4, let's say the velocity is 3 meter per second. Okay, So what is the difference between any 2 points here? The difference between this point and this point will be 1 meter per second. The difference between these two will be 4 meter per second. Difference between these two will be 2 meter per second. Here it will be minus 4 meter per second, because final is 3, initial is 7. So when you subtract, you'll get minus 4. Okay, so in every 1 second time, you find that the velocity is changing at a different value. Okay, or I can see here that the velocity is changing by an equal amount in equal interval of time. So when this body is moving, then it is accelerated because the velocity is changing. But the type of acceleration that the body is having in this case, it is a variable acceleration. Okay, so that is the meaning of variable acceleration. Okay, next is average acceleration. Okay, so this average acceleration, it is defined as the just like average speed and average velocity. And here we define the average acceleration as the ratio of the total change in the velocity to the total time taken. So therefore, for average acceleration, I'll write A with a bar on top of A, which means average. So this average acceleration is equals to how much the change in the velocity upon time taken. So if you consider that the initial velocity at time t1 is v1 and the final velocity at time t2 is v2, then the average acceleration means the total change in velocity, which is v2 minus v1, upon the total time taken, which is t2 minus t1. So this is the average acceleration. Number 4, instantaneous acceleration. The instantaneous acceleration is defined as the acceleration at a given instance of time. And we can prove this mathematically, graphically, like for average, for instantaneous velocity, we can prove this also similarly in the same way. And you will get this acceleration, the instantaneous acceleration at a time t is equals to limit delta t tends to 0, delta v upon delta t. Or this instantaneous acceleration, it can be replaced as, instead of this limit, we can write dx, sorry, it's dv upon dt. Or a is equals to d dt. Okay, you know v. V is how much? V is dx upon dt. Or I can say acceleration is equals to d2x upon dt2. So this is the instantaneous acceleration at a time t. Okay. So if you look at this equation, number 1, I can say that this acceleration is equals to the first order derivative of velocity. Or from equation 2, this acceleration is equals to the second order derivative uh, of the displacement x. Okay. All right. Next, the third type is, the fifth, right? The fifth type of acceleration is positive acceleration. So what do we mean by positive acceleration? So when the velocity of a moving body is increasing with time, that means the body is get accelerated, and so the acceleration is said to be positive. So positive acceleration means velocity is increasing with time. Number 6, negative acceleration. If the velocity of the moving body is decreasing with time, if the velocity is decreasing with time, then the accelerations of the body is said to be negative acceleration. Another word for negative acceleration is sometimes we call retardation. Okay, So retardation is the negative acceleration. All right.